All right, ready to dive in. Today we're looking at vision language models, VLMs. You sent over some research on a new method, ALIGNVLM, and it looks really interesting. So we're going to break it all down, figure out what's important, and hopefully have some fun too.
Sounds good.
Just to get us started, VLMs are basically AI that can understand, like both images and text. Imagine asking a computer about a financial report. It reads the words, but it can also look at the charts and graphs all at once.
Yeah, it's like giving AI a whole new way to see the world.
Exactly. So what's so special about ALIGene VLM? What's it bringing to the table?
Well, ALIGNVLM is trying to solve this core problem.
Yeah.
How do you bridge the gap between like visual data and text data? Traditional methods that kind of struggle with that.
Yeah, that makes sense. The paper mentioned these things called MLPs, multi-layer perceptrons, and how they can cause issues. I'll be honest, I had to, Google that one.
MLPs, yeah, they're a common tool. But when you're trying to get visual data and text data to work together, it can be a bit of a mismatch. It's like trying to fit square blocks into round holes. The information doesn't quite line up, and that leads to, well, mistakes.
So ALIGene VLM is coming in with a more, elegant solution.
Exactly. Instead of forcing that direct connection, ALIGNVLM takes those visual features and it maps them to something called probability distributions. It's basically translating that visual information into a language that the large language model, the LLM, can understand.
Oh, so it's like ALIGene VLM is teaching the LLM a new language based on visuals, but it's building on what the LLM already knows. That's pretty clever.
Right. And by staying within that framework of what the LLM already knows, ALIGNVLM avoids throwing in a bunch of stuff the AI might not get. So it reduces the noise, so to speak, and that leads to much better accuracy.
It's not just understanding, it's understanding clearly. And that's got to be where those crazy impressive results come in, right?
You got it. ALIGNVLM is beating other methods on all these benchmarks like DocVQA, InfoVQA, and it's doing it, even compared to some models that are much bigger and more complex. What's really neat is that it's also more efficient computationally. It's smarter, but it's also faster and leaner.
All right, I'm hooked. Now, there are a couple of things in the paper that really stuck out to me. One was this observation that ALIG and VLM seems to associate white space, like the blank spaces, with punctuation marks. It's almost like it's figuring out the grammar of how things are laid out visually.
Right. That's a really insightful observation. It might seem small, but it shows us that ALIGNVLM isn't just recognizing the words. It's understanding how they fit together visually within the structure of the document. That's a huge step toward, actually comprehending what a document is saying.
Totally. And then there was this other thing about how it did on the VCR benchmark, which is all about restoring text. ALIG VLM can actually use those tiny little visual clues at the pixel level to restore text that's missing, even if it's partially obscured. The possibilities there are just
Huge, yeah. Absolutely. Think about a historical document that's damaged or, I don't know, some piece of evidence where the writing has faded. ALIGNVLM could actually help us bring back that lost information.
Yeah.
For history, for archaeology, even criminal justice. It could be revolutionary.
And the paper even called out some specific fields where ALIG and VLM could have a huge impact. Finance, healthcare, law.
Imagine like a system that can read a financial report, not just read it, but understand the trends, find the things that are out of place, see the potential problems that are hiding in the data. Or in healthcare, processing medical records instantly, picking out the crucial information a doctor would need.
It sounds like ALIG and VLM could be a total game changer for so many industries. We're talking about automating stuff that takes humans, like hours and hours, even weeks sometimes, and doing it super accurately.
And it's not about replacing humans altogether. It's about giving those experts the tools they need to be more efficient, to work more effectively. It's about taking human intelligence and adding AI to it, augmenting it.
So we've talked about the problem, the solution, and the benefits.
Mm-hmm.
But here's what I'm really wondering. Where does this all lead? If ALIG and VLM is already this good at what it does, what's the future of document understanding? Where do we go from here?
That's the big question, isn't it? If AI can understand documents like this, does that mean are we moving towards systems that can truly understand how we communicate? Both the visual stuff and the text, all of it.
That's an amazing thought. Definitely something for everyone listening to think about. We'll be back soon with part 2 of this deep dive to explore ALIG and VLM even further. All right, welcome back to our deep dive on ALIG VLM. So last time we left off with a pretty big question. Is AI on the verge of actually understanding how humans communicate? Like
Yeah.
really getting it. But before we get too deep into, the philosophy of it all, I think it's worth taking a closer look at how this thing actually works.
Yeah, definitely. I mean, if you really want to appreciate what ALIG and VLM can do, it helps to understand how it's all put together.
Okay, so break it down for us. What are the main parts of this AI marvel?
You can think of ALIGNLM as having like three main components.
Yeah.
Okay, so first you've got the vision encoder. This is the part that like processes the visual data. Whether it's a scanned document, a photograph, or even something more complex like an infographic. It's like the eyes of the system.
Gotcha. So it's taking in all that visual information and making sense of it.
Right. It takes the image, breaks it down into these smaller pieces, and pulls out the key features, sort of like how our brains process what we see.
And then those features get passed along to the LI module, right?
Exactly. This is where the real magic happens, I think. Remember how we talked about ALIG and VLM translating the visual information into something the LLM can understand? Well, this is where that translation happens. The ALIG module takes those visual features and maps them to probability distributions. Essentially, it's figuring out how to express those visual ideas using the vocabulary the LLM already knows.
Okay, I got to be honest. That sounds a little technical. Can we break that down a bit more? For the folks listening who might not be AI experts.
Sure. Think about it this way. Imagine you have this picture book, but there are no words, and you want to explain what's happening in the pictures to someone who doesn't speak your language. The AI module is like a super smart translator. It takes what it sees in the pictures and finds the closest matching words in the other person's language.
Oh, I see. So it's not a direct translation. It's more like it's figuring out the best way to describe what it sees using the words the LLM already has.
That's a great way to put it. Yeah, it's about finding the most accurate way to represent that visual stuff using the LLM's like internal dictionary.
That makes a lot more sense.
Oh.
All right, so we've got the vision encoder, the A-line module. What's the third part?
The large language model, the LLM, this is where all the knowledge is, the reasoning power. It takes that aligned visual input, the stuff from the A-line module, and uses it to, do whatever task it's been given, answer questions, generate responses, all that.
It's the brains of the whole operation.
You got it. The LLM is where all the heavy lifting happens when it comes to actually understanding and processing all that information. The paper mentioned they used the Llama model family for their experiments, specifically Llama 3.1 and 3.2. Those are known for like being really good at language tasks. So it's like they built this amazing VLM on top of an already super powerful foundation.
That makes sense. Okay, so let's talk about how this whole system learns. The paper talked about a multi-stage training process, and it sounded pretty intense, to be honest.
Oh yeah, it's definitely a carefully designed process. Each stage is really important. First, they train the A-line module on a massive data set of like image text pairs. This is where the model learns to connect those visual features with the words and concepts in the LLM's vocabulary, kind of like teaching it a visual dictionary.
So it's learning to speak the language of both images and text.
Exactly.
Ah.
And then they move on to document understanding. They use this special data set called Big Docs, which has like tons of different kinds of documents. This is where it learns about, the structure of a document, headings, paragraphs, tables, charts, all that.
It's like ALIG and VLM is going to document school.
Haha, yeah. And finally, there's this stage called instruction tuning. They fine-tune the model on a data set called doc downstream, which is specifically for tasks like question answering. This is where it learns to follow instructions to actually perform those tasks correctly. It's like, giving it a set of tools and showing it how to use them.
So it's going through this like training gauntlet to become a true document master.
You got it. All those impressive results we talked about earlier, outperforming other models, being so efficient, it's all thanks to this really smart three-stage training approach.
It's pretty amazing when you think about it. And speaking of those results, let's talk about the real-world stuff for a minute. What kind of impact could ALIG and VLM have? We touched on a few areas last time, but I'd love to hear more of your thoughts on where this could all lead.
Well, the possibilities they're pretty vast, to be honest. Think about information retrieval. Imagine a search engine that doesn't just find documents with your keywords, but actually understands the context of those keywords within the document and how they relate to any images or charts.
It wouldn't just be finding documents. It would be like really understanding what they mean and pulling out the most relevant information.
Exactly. It would totally change how we access and use information. And then there's document summarization, right? ALIG and VLM could potentially create concise summaries of these long, complicated reports, highlighting the key points and even pulling out data from tables or figures.
That would be huge for anyone who has to like slog through mountains of paperwork.
Yeah.
Lawyers, financial analysts,
Oh,
researchers.
absolutely. It would save so much time and make those complicated documents so much easier to digest. And then, of course, there's the potential for automated data entry. ALIG and VLM could pull information from invoices, forms, receipts, and automatically put it into a database.
No more manual data entry. Sign me up.
Right. It's all about making information, making it more accessible, more usable. And, as the technology keeps evolving, I think we'll see even more innovative applications emerge.
This is all super exciting, but I think it's also important to, you know, acknowledge that there might be some challenges too, right? I mean, the paper mentioned the issue of noise in visual data.
Yeah.
Real-world documents, they're not always perfect. They can be blurry, have handwritten stuff on them, or just weird layouts.
Yeah, you're right. It's a good point. I mean, ALIG and VLM is designed to be pretty robust, but those imperfections, they can definitely still be a problem. There's definitely more work to be done, to improve how it handles that kind of noisy data.
And I imagine the training process itself is a big hurdle too, creating those massive data sets for VLMs. It can't be easy.
Yeah, it's definitely resource intensive, and sometimes, the limited availability of high quality training data, it can kind of slow down the development of these models.
So there's still obstacles to overcome. But it sounds like the future of ALIG and VLM and VLMs in general is incredibly bright.
Oh, absolutely. I mean, as researchers keep refining these models, coming up with new training techniques, the possibilities are pretty much endless.
It's amazing to think we're like right here watching this technology emerge. It could totally change how we interact with information.
For sure. And as we move forward, it's really important that we approach it, with a balance of enthusiasm and caution. We have to think about the ethical implications, the impact it could have on society.
That's a great point.
Yeah.
Now, you mentioned earlier that ALIG and VLM is a big step forward for what are called shallow fusion VLMs. Can you explain what that means? Like, where does it fit into the bigger picture of vision language models?
Of course. So in the world of VLMs, there are two main approaches to integrating visual and textual information: shallow fusion and deep fusion. Shallow fusion models like ALIG and VLM, they basically try to integrate those two types of data efficiently without, completely changing the underlying language model.
So it's about finding that balance between performance and efficiency.
Exactly. And ALIG and VLM is a great example of how powerful shallow fusion can be. It's showing us that we can get really amazing results without, overcomplicating things.
That's fascinating. I'm guessing there's a trade-off somewhere, right? What about those deep fusion models? What are they doing differently?
Well, deep fusion models like Flamingo or CogVLM, they take a deeper approach. They try to incorporate the visual information more directly into the language model itself,
Yeah.
adding new layers or changing existing ones to really weave those visual and textual features together.
So they're like blending those two things together at a much deeper level.
Right. But that comes at a cost. Deep fusion models, they can be much more demanding computationally. They need a lot more processing power, and the training takes much longer.
It's like a trade-off between complexity and efficiency.
Yeah, you could say that. Deep fusion models, they have the potential to achieve even higher levels of understanding, but they need a lot more resources. What's so exciting about ALIG and VLM is that it's showing us that shallow fusion, it can be incredibly effective, even outperforming some of those more resource-intensive models.
It's like finding a clever shortcut instead of rebuilding the whole system.
I like that analogy. And, this trend towards efficiency, it's something we're seeing all across AI right now. Researchers they're working really hard to make these powerful models more accessible, more sustainable.
That's great to hear. Especially as we think about, using VLMs in real-world situations where resources might be limited. Now, I know we've been focusing a lot on document understanding, but I'm curious about other applications. What other areas could VLMs have a big impact on?
Oh, there's so many. One that I'm really excited about is the potential for VLMs to boost human creativity. Imagine being able to describe, a concept, a scene, and then an AI system can generate a super realistic image or even a video based on your words.
Oh, that sounds straight out of science fiction.
Right. But it's becoming more and more real. We're already seeing some early examples of this kind of AI-powered creativity. And I think it could completely revolutionize things like art, design, even storytelling.
It would be like giving everyone the power to bring their imagination to life.
Exactly. And think about what it could do for scientific discovery. VLMs could help scientists analyze these huge, complex data sets, find patterns, even come up with hypotheses that human researchers might miss.
It's like having a super-powered research assistant.
Right. And I think VLMs could also be incredibly important for personalized medicine. Imagine an AI that can look at your medical records, your genetic data, your lifestyle, all of it, and then create a truly personalized health plan just for you.
That would be amazing.
Right.
Like having a doctor who knows you inside and out.
Yeah. And what about the potential for VLMs to help us, understand our history and culture better? Imagine an AI that can analyze ancient texts, artifacts, works of art. It could uncover these hidden meanings and connections that we've missed.
Wow. It's like having a time machine to unlock the secrets of the past.
It really is. The possibilities they're just mind-blowing. But, as we explore all these exciting new frontiers, it's so important that we do it responsibly. We have to think about the risks, the challenges, and make sure these AI systems are developed and used ethically, with a focus on benefiting humanity.
Absolutely. With any powerful technology, there's a responsibility that comes with it. We have to think about the impact it could have on society, on jobs, on our privacy. And we have to have these open, honest conversations about, how to shape the future of AI in a way that aligns with our values.
Well said. It's not just about the technology itself. It's about the choices we make, about how we develop it, how we use it.
All right. So as we wrap up this part of our deep dive into ALIG and VM, I think the big takeaway is this. We're seeing the emergence of a technology that could completely change our world. It's exciting. It's a little scary. It's full of possibilities and challenges. But ultimately, it's up to us to decide how we want to use it.
I couldn't agree more. It's a journey that requires, both curiosity and caution, a willingness to embrace the unknown, but also stay grounded in our ethical principles. And who knows what amazing discoveries are waiting for us.
That's the best part, right? The future of VLMs is still being written, and we all get to be a part of shaping it. We'll be back soon with the final part of our deep dive into ALIG-NVLM. But for now, we hope this is, giving you a taste of just how powerful and potentially world-changing these vision language models can be.
Right.
Welcome back for the final part of our deep dive into ALIG-NVLM. When we started this whole thing, I thought we were just going to be talking about documents, right? But it's clear now that this technology, it goes way beyond that. It's about like the whole way we interact with information, even like on a basic human level.
It really shows how everything is connected.
Right. And that brings us to a pretty important question. What is ALIG and VLM? What does it tell us about the future of all these visual language models? What are the big trends,
Okay.
the breakthroughs, the challenges that are shaping this whole field?
That's a good question. I think one thing that really stands out, one of the big things, is this focus on efficiency. We talked about how well ALIG and VLM does with that shallow fusion approach. It's like it's showing us we don't always need to build these giant, super complex models to make real progress.
Right. Work smarter, not harder, as they say.
Exactly. And that makes sense, right? If we want to see these AI systems actually being used out there in the real world, we got to think about places where resources might be limited.
That's a really good point. It's not just about the computing power. It's also about like making these tools available to more researchers, more developers.
Yeah.
People who, might not have access to those massive resources.
I think so. The more people have access to these tools, the more innovation we'll see. It's like democratizing AI in a way.
Totally. And another trend, it seems like, is this move toward like more specialized VLMs. Like ALIG and VLM, it's built for document understanding, and it's really good at it.
Yeah. It's like using the right tool for the job, right? Instead of trying to build one model that does everything, we're starting to see these VLMs that are, fine-tuned for specific tasks or specific industries.
That makes sense. Now, we've already talked about a lot of potential uses: information retrieval, summarization, automating data entry, education. But I feel like, honestly, we've just scratched the surface. What are some other areas where you see VLMs making a real difference in the future?
Oh, wow. So many. One that I think is super exciting is how VLMs could boost human creativity. Imagine a world where you could describe an idea, a scene, anything really, and an AI could create a realistic image or even a video of it based on your words.
That sounds kind of like magic almost.
Right. It's like straight out of science fiction. But
Totally.
it's becoming more and more possible. We're already seeing the early stages of it. And I think it could completely change, art, design, how we tell stories, all of that.
It would be like giving everyone the power to like make their imagination real.
Exactly. And imagine what it could do for science. VLMs could help scientists analyze all that data, find patterns, come up with new hypotheses, things that maybe humans wouldn't even think of.
Like a super powered research partner.
That's a good way to put it. And think about personalized medicine. What if an AI could look at your medical history, your genes, your lifestyle, and create a custom health plan designed just for you?
That would be incredible. Like having a doctor who knows you better than you know yourself almost.
Right. And then there's history and culture and AI that could analyze old texts, artifacts, artwork even, uncovering all these hidden meanings and connections.
Like having a time machine,
Yeah.
to unlock all those secrets from the past.
It really is. The possibilities are just incredible. But, as we explore all these exciting things, we got to be careful. We have to think about the risks, the challenges, and make sure that we're using this technology ethically in a way that benefits, all of humanity.
Yeah. Any powerful technology, it comes with a responsibility.
Mm.
We have to think about the impact it could have on society, on jobs, on our privacy, and we need to talk about it. Have those open and honest conversations about how to build the future of AI so it aligns with what we believe in.
I completely agree. It's not just about the technology itself. It's about, the choices we make as humans about how to develop it, how to use it.
So as we wrap up this deep dive into ALIG and VLM, I think the big takeaway is this. We're at the very beginning of something that could completely change our world. It's exciting, it's maybe a little scary, it's full of possibilities and challenges, but at the end of the day, it's up to us to decide how we want to use it.
I think that's a great way to put it. It's a journey, right?
Yeah.
And it requires curiosity, but also caution. We have to be willing to explore the unknown, but also stay grounded in our ethics, in what we believe is right. Who knows what amazing things we'll discover along the way.
That's what makes it so exciting. The future of VLMs, it's still being written, and we all get to be a part of it. Thanks for joining us for this deep dive. We'll see you next time for another exploration into the world of tech and innovation.